Morning, everyone. Welcome. Pleasure to be here. And on behalf of NAB and NAB Labs, it's a pleasure to be involved with the ATSC 3.0 development and also to be a sponsor of this event. So what I'm doing is just really a very basic, high-level first step overview. And in fact, I'm definitely preaching to the choir here. The fact that you're all here, I think, makes it clear that you already understand what a lot of what I'll be talking about. Pardon me. It's tough when you're the first speaker. It's still too early. But just to do a little level set, for those who may not remember or be completely familiar, we want to review at least what the goal is for ATSC 3.0. First of all, obviously, we want to make TV better. We also need to address the fact that our audiences are continuing to change and expect more. And we're trying to reach them in more places than we ever have had to try to reach them before with television. We're obviously trying to keep the broadcast industry vibrant and alive and relevant and continue to have it grow. And we're trying to do this in a way that is fairly unrestricted and relatively unconstrained in terms of the flexibility for change. Obviously, there is a downside to lack of backward compatibility, so that has to be balanced with a propensity towards great advantages being enabled by such another transition. So that's been kind of our highest level set of goals when we started this whole thing. And we've made these decisions based on the fact that there is a value proposition that makes it worth doing. For one thing, it's hard to believe, maybe, for some of us, or as Mark said, maybe it's just we're getting older and time seems to slow down, but it looks like we're getting towards a couple of decades from when ATSC 1.0 first started, and that's you know, in the age of the internet, the digital world, that's a long darn time. And as I mentioned, audiences continue to change and grow their expectations seemingly on a weekly basis. We certainly have a lot different competitive environment than we did back in the ATSC 1.0 days. Much lower barriers to entry for new competitors, and so how does broadcasting really sort of rework itself to plug into that environment and have the flexibility, the agility that it needs to compete in that space with all these new and different types of players. We have a valuable resource that we benefit from, that we're using as broadcasters. Clearly, the over-the-air spectrum, it's a challenging and scarce resource, and certainly there are others who would like to use it as well. So we'll hear more about that tomorrow, but the idea that we want to be as circumspect as we can and as prudent and as efficient as we can in our use of that scarce resource is one of the key elements to doing this, making this change, particularly at the physical layer. And finally, I think one of the things that we've had the promise for many years, but have never actually been able to leverage fully, is this promise of the merging of over-the-air and online services. You've heard the term convergence and convergence 1.0, 2.0. We've heard it for many years, and it is appealing, at least on a theoretical level. This time we're hoping to make it real. So we have this opportunity with this new standard to from the start, integrate rather than try to bolt on or munge together some kind of a kludge of different technologies, to have it be integrated from the beginning, to be both an over-the-air and online service in as seamless a way as possible, to really leverage what is clearly a powerful resource of putting those two things in a single device, a single service. And it takes a lot to do that. It takes both on the consumer side as well as on the broadcaster side to try to get a service that that really efficiently does that. So it's a big learning curve as well as a technology jump. But I think the power, again, is so potentially high that it's appealing enough to make us all sort of work together to try to get this to a sort of sea change of delivery technologies or convergence to actually work. Broadcasters certainly have a stake in this. Clearly, they want to keep their audiences as big as possible, but they also want to get to these new devices and new platforms that consumers increasingly are turning to. And if television can be on those platforms, all the better. We certainly have a lot of new technologies that we can utilize both in creation and delivery of television content. We want to see the ability for both our quality to improve, certainly, like it did in the last transition, but also our quantity of services, at least potentially, to be able to also increase, as they also did in the last transition, but this time sort of to the square that potentially. So we'll see if that can happen. And certainly, if there's the possibility for new business opportunities to be part of that, all the better. We spent a good bit of time talking with amongst ourselves here in the U.S. and our colleagues around the world in trying to come up with what the high-level specific goals were, not just in these sort of flowery terms I've been using on these bullets, but the actual requirements, or at least the scenarios, the use cases. And so we did a pretty exhaustive bit of work on that in the early days, particularly in the group that I chair as 31, which is the group that developed the system requirements. And these are the baker's dozen or so top-level requirements we came up with, or scenarios we came up with for usage. And all the work that's taken place in ATSC 3.0 that what Mark was talking about has flowed from these. All of the work serves one or more of those goals. I won't go through them all right now. You're probably familiar with most of them. But you see all the sort of hot buttons that we're trying to plug into this big job of ATSC 3.0. It's not just a delivery standard, it's a delivery and transport and application standard. So it's a lot of pieces, a lot of work, and some way or another, all of those 13 requirements or scenarios are really trying to be satisfied to some, hopefully, high degree of realization. So finally, I'll end up with just giving us a look at the timing of all this. This is not a new effort, as many of you know. We started this about 5 years ago, actually. So again, doesn't seem like that long, but it has been. Time flies when you're having fun, I guess, or something. We have started planning back in the 2010 era with the planning teams. Planning Team 2 actually created this effort, and it kind of gave the rationale for doing it. And then once that was, the board of directors decided it was a go, we got the green light to start doing those requirements. And as I said, that was a long effort in itself. Couple of years almost spent on developing the requirements the specific requirements that flowed out of those 13 scenarios ends up numbering somewhere just south of 150. So there's a lot of requirements in our list that we're now working on developing the actual standards, specifications to make happen. And, of course, that's where we are now in the period of developing those standards, and we hope to see the first products start next year. So just to give us a little marker, this thing keeps moving along. We're kind of getting towards the end of this standards period. As Mark mentioned, the first actual candidate standard draft appeared a week or so ago, or was approved a week or so ago, and we're now going to see probably a flurry of additional documents start coming down the pike. We'll talk more about those in detail throughout today, and I think you'll see what our philosophy is in not taking a monolithic approach to one big standard, because this is such a big effort. The actual standards documents are going to be a suite of many specific smaller documents that hopefully will all fit together, and then also have better ability to be updated individually over time. And we're using a layered approach, again, like the classic layered advantages of networking, the computer networking and the internet and so forth, the ability to change one thing and leave the rest alone is important for the ability to have greater flexibility in migrating the standard going forward, so that hopefully increased future change, because none of us are crazy enough to think that this is going to be the end of this path, that we're going to have it all figured out forever. It's going to continue to need improvement over time, and so we want to make sure that we're not only setting the bar high enough to make a nice big jump now, but also making the ability to make increased jumps later that much easier in small incremental ways. Over time, without having to be sort of locked in and waiting till another 20 years goes by before we go through one of these big processes again. One thing we're all learning is that, yeah, all the fun we're having, we'd like not to have it again in our lifetime. So we'll see if we can make that happen as part of this process as well. So that's the end of my super high-level overview. Turn it back over to Rich, and he'll drill down a little bit more about how this is all happening within ATSC. Thanks.
Okay, so I'm going to essentially try to set the stage for the remainder of today. Talk about what's going on and where it's going on. This is the caveat. Mark mentioned this. Point is, this is a snapshot of what's going on in ATSC. It's a view of where we are right now. Until it goes through full process, ballot at TG3, and by the full membership, it's subject to change. But it's our best representation of the technologies we have in place right now. So Skip covered this, ATSC 3, flexible, scalable, configurable, interoperable, adaptable, lots of goals. The intent is to create a broadcasting standard that goes well into the future and can evolve over time. We learned a lot in the past. The diagram on the lower right is Moore's Law. There's debate about whether it's going to continue at the same pace. I don't think anybody's going to argue that technology is going to stop changing and evolving. So we learned that rather than ignore all of this, let's create a method to evolve the system gracefully. Through the use of versioning, through the use of signaling technologies in other layers, we think we're building something that can be evolved rather than simply replaced through a major effort like we used to have to do. So Skip talked a little bit about S31 requirements. The work that was done there, set the scenarios, requirements, has been addressing questions, and has gone on to more of a project management role, prioritization, keeping the big picture in mind, making sure nothing falls between the cracks, and ultimately verifying that the requirements are fulfilled. So the next sequence of charts is really going to talk about what do we need in the system. So the first thing we need is a way to broadcast bits to a multitude of receivers simultaneously, make efficient use of spectrum, control robustness, be able to pick operating points that match what the broadcasters need, and to utilize multiple operating points simultaneously. Some broadcasters may want to deliver both high quality, high bit rate fixed service and very robust mobile services. The ability to reach all devices. It's not only the big screens, it's the little devices in your pocket, tablets, basically anything that can receive television should be able to receive television. And the ability to utilize different network topologies. This is the work going on in S32 physical layer, which you'll hear about next. Moving up, we need a way to transport the components to the receiver. Both broadcast and broadband. We have to move bits in and out of the physical layer. We've got to organize the bits that represent the components of the service, associate components to services, and to synchronize components. You know, lip sync, it goes beyond just audio and video synchronization. Interactivity and other things need to be synchronized as well. Simple things like a guide to the viewer. People expect personal services these days, so the ability to personalize things is important. And in many cases, broadcast television is actually viewed through an intermediary, MVPD. So a way that the television can understand what's playing, even if there's something else in the way. This is the work going on in S33, the layer for management and protocols. What else do we need? We need pretty moving pictures. UHD, 4K initially, but it's more than that. High dynamic range, extended color gamut, high frame rate, and these are all aspects of video. We've got to handle large devices, small devices, and we need as efficient coding as possible. Spectrum is scarce. The better use we can make, the less bits it takes to get a quality picture, the better. Audio. Immersive audio is getting better. It's more immersive these days. There's abilities to personalize. People would like to have the ability to select, for example, which announcer is speaking during a sporting event. Home team, away team. I don't like announcers. Let me hear the crowd. Different devices, different speaker configurations, the ability to render a single audio stream to what the environment is at the receiving side is important. And things like loudness, dynamic range control are still part of the picture. We need to support accessibility, including captions, and applications and interactivity. This is the work going on in S34, the applications and presentation layer. What else? Well, we're building a new system, a lot of new technologies. We need to understand what the station architecture is. We need to provide guidance to people creating new stations. It may not exactly match what each station builds, but something that's general enough to be used as a guide that resembles all of them is a big assistance. This is the work going on in S35. More things. Business side. We need to be able to support subscription, pay-per-view services, security for broadband services, two-way trust between primary and secondary screens, certificates, revocation of same, security for interactive applications. Very, very important stuff. This is going on in S36, security. The ability to present and support personalized, interactive, and engaging experiences. Give people what they're coming to expect. Television is not simply sit back and watch, although people may want to do that. They also want to be able to interact, be able to do more personalized things. Enhanced program data, support second screen, targeted advertising, ad insertion. This is the work going on in what's called the PIIT, Personalization and Interactivity Implementation Team, which used to be the ATSC 2.0 implementation team, refocused. I'd like to just call people's attention that this activity is picking up. Dave Siegler is running that. And lastly, we need a means to distribute emergency alerts to all receivers in an affected area simultaneously. A means to wake sleeping receivers, let people know there is an emergency. Be able to efficiently broadcast rich media, something more than there's a problem in your area. Things like evacuation maps, weather maps, and a means to geographically target emergency alerts. This is actually work going on in a multitude of places, but there's another implementation team focused on this, the Advanced Emergency Alert Implementation Team. You'll hear about that later too. This is the structure of TG3. Lots of specialist groups and focused ad hoc groups within the specialist groups. Kind of complicated. There's an awful lot of work going on. You'll hear about the majority of these today. Document structure, as was mentioned, it's not going to be a single monolithic standard, which would actually be a total nightmare to maintain. Roughly speaking, it's a group of standards for each layer, broken up into parts. It's going to look something like this. And I realized this morning that I didn't quite get the diagram right. This is still evolving a little bit. This is a pretty good preview of the standards that will be out. The one at the bottom right system discovery and signaling part is actually in candidate standard status right now. It's been published, it's available on the ATSC website. So if you'd like to see what an ATSC 3 candidate standard document looks like, go to the ATSC website, you'll find it in the candidate standard section. Overall schedule, key thing to take from here is we're targeting to get the majority of the candidate standards into ballot by the end of the summer, early fall. There's a few little lag past that, but we're working very hard to get these into that status around then. Candidate standard is when we have a document drafted, we think it's in good shape, we think it's correct, we think it's ready for ballot. After ballot, it's in this candidate standard status period for a while. People get to implement and find out, and we get to find out if what we wrote is read by others in the same way we intended. People get to try it, implement it, and it's relatively easy to make modifications during that time. When we decide it's correct, it's been implemented, things are good, we can put it out for proposed standard ballot, after which it becomes a published standard. You'll hear a lot more about this tomorrow. There are some challenges coming up. Transition, how do we get from here to there? Some problems. Spectrum challenge, there isn't spare spectrum, so broadcasters can borrow spectrum for a while. There are some possibilities to address this, but it is being worked on. There's also a challenge on the receiver side. Since it's not backwards compatible, how do we take care of people, the large number of people that have devices in the home? And there's a number of ways being looked at to do this. There's work going on in a lot of different places beyond ATSC. Next steps, we're working very hard to complete the standard, develop transition scenarios. Commercial launch is in the future. And key thing is that industry collaboration is essential, and it is happening. Participants in ATSC range from broadcasters to consumer device manufacturers to universities to equipment manufacturers and international. People from all over the world are participating and contributing to ATSC 3.0. So in summary, 3.0, it's not going to be backwards compatible. It does acknowledge the changes in the user environments and needs. It really does understand broadcast spectrum regulation issues. It supports the viability in new business models of broadcasters, very important, and it's very flexible. We think it'll be able to accommodate future improvements and developments as gracefully as possible. So that's my presentation. I guess after each of these, if there are questions, we can take them. Any questions?
What would the spectrum regulatory concerns be?
Tomorrow, there'll be lots of discussion on that.
6 meg channel.
Tomorrow.